Hello everyone, welcome to Geeks for Geeks. Today we will see tutorial on identical linked lists. Let's see the problem statement first. The problem statement says given two singly linked lists, we have to write a function to check if the given two linked lists are identical or not. First, let's see when the two linked lists are said to be identical. Two linked lists are identical when they have same data and arrangement of data is also same. Let's see some examples. In the first example, we have given first linked list as 1, 2, 3 and second linked list as 1, 2, 3. Since both linked lists have same data with same arrangement, output will be identical. In the second example, we have given first linked list as 1, 2, 4, 3 and second linked list as 1, 2, 3, 4. Since data of the third node of both the linked list don't match, output will be not identical. First, let's see iterative method to check whether given linked lists are identical or not. First task is to start traversing both the linked list simultaneously. While traversing, compare data of both the linked list. If at any node the data is not matched, return false means lists are not identical. Else if both linked lists are fully traversed, return true means lists are identical. Let's see the C implementation of above algorithm. Return type of this function is bool since it will return true or false telling whether the given linked lists are identical or not. The function takes two arguments, head of the first linked list A and head of the second linked list B. We will then start traversing both linked lists simultaneously. If data of current node of first linked list A data is not equal to data of current node of second linked list B data, then we return false means linked lists are not identical. Else, if both A and B are not null, then we move to next nodes in both lists and compare data of next nodes. We continue traversal till both A and B are not null. Once if either A or either B or both becomes null, we stop the traversal. Finally, we return A equal to null and B equal to null. For linked list to be identical, then A and B both must be null, means both pointers should reach end of the linked list, else linked list will be not identical. Now let's see the recursive algorithm for the problem. So if there are one or more than one nodes present in both linked list, then match data of current nodes and recursively call the function for rest of the nodes. If data of all the nodes matches, final output will be true, else output will be false. Let's see the recursive code and understand it using an example. So we have given two linked lists, first linked list as 1, 2, 3 and second linked list as 1, 2. So we have to check whether these both linked lists are identical or not. So initially, head of first linked list A will point to 1 and head of second linked list B will point to 1. Since A and B both are not null and current node data of both linked lists are same, which is 1, it will recursively call the function are identical and check the same for A next and B next, which is 2 and 2 respectively. Now since current A data and B data both are 2 means both are equal, we will recursively call the function are identical on next of both current A and B, which are 3 and null respectively. Now since B is null, it will not enter in the first condition, neither it will enter in second if condition. Since we have reached end of one of the second linked list, it will return false to the calling function. So here, since 2 is equal to 2, so it will return true. And boolean AND of true and false which is false, will be returned to are identical 2, 2. So finally, we are left with 1 equal to 1 and false. Since 1 is equal to 1, so it will return true. Boolean AND of true and false will finally return false. So we get final output as not identical. So this completes and verifies our algorithm. Time complexity of both iterative and recursive algorithm is O(n). N is the length of the smaller list among both lists. Note that though time complexity of both the methods are same, but with respect to space complexity, iterative code here is more efficient since recursive code uses unnecessary system stack space. With this, we end our tutorial. Thank you for watching. Please leave us your likes and comments.